is solving exponential and logarithmic equations. So now we're going to have equal signs and we're going to have to solve the equations for our unknowns. So there's two basic strategies for solving exponential and logarithmic equations. So we'll have two types of equations. There's going to be a couple types of exponential equations, but the same rules are going to apply for every single exponential equation. Then there's going to be two different types of logarithmic equations. And at the end, I have those listed out for you guys. So if you're like, whoa, that's a lot of problems and a lot of things to remember, it's all listed at the end of your notes. Okay. First is based on the one-to-one properties, and the second is based on the inverse properties, which we talked about yesterday. So we have these following properties. If you have the same base, you can set your exponents equal, because if you have 5 to the x power equals 5 squared, then you know that x has to be 2. So that 5 squared equals 5 squared. And same thing here, we already looked at this property. If your logs are the same, you can drop them, and we get x equals y. The arguments are equal. These are inverse properties. We're actually not going to use our inverse properties that much. Instead, we're going to use the definition of a logarithm instead of using the inverse properties. But we did look at these in our notes yesterday. We said those cancel, and we just get the exponent x. And we said these cancel, and we just get the exponent x. Okay? Or I guess here it was the argument x, and here is the exponent x. Okay, so here's a bunch of different examples. So there's 5 questions on the first page of your homework that are similar to these, so you guys can use this to help you. We're going to do an example like A, so I'm going to skip that one. B, they added this log over to the right side, and now you can drop the logs because they're the same, and we just get x equals 8. Right? Same thing for this one. They added the natural log of 3 over to the right side, and because we have natural log on both sides, we can drop the natural log, and we just get x equals 3. And we'll do an example like D, so we'll come back to that one. Then this second half, they're using the inverse property. Like I said, we're not going to use the inverse property. You can, but we're going to use the definition of logarithm, aka swirling. Okay, so we will do an example like E, so I'm going to come back to this one. And then the natural log, I'm always going to rewrite that as log base E, because that's what it is by definition. So log base E of x equals -3. And then we're going to swirl. E to the -3rd power equals x. Right? So e to the -3rd power equals x, and we're done. Right? Here, again, we're just going to swirl. 10 to the -1st power equals x. And then 10 to the -1st, we can simplify and say 1/10. Right? And then same thing here, we're just going to swirl. 3 to the 4th power equals x, and 3 to the 4th power is 81. Right? So again, you can use the inverse properties like they show you here, but using the definition and swirling, that's how I'm gonna do it, because I think it's good to just keep it consistent. I think this can get very confusing at times. And then we'll do an example like A, D, and E. All right, we're going to solve a bunch of exponential equations. The first step is that we need to isolate the exponential term. Once we've isolated the exponential term, we can take the natural log of both sides. I know this says take the logarithm. We're going to take the natural log of both sides. So, solve the exponential equation. We don't actually have to follow that here. We're going to use this property. So when you have the same base, you can set the exponents equal. So what we want to do here is get the same base. Okay? So 3 to the x power equals 3 to the, I think it's 6. That's 6th power. Oh, maybe it's 5th actually. 3 to the 5th power. Yeah, 3 to the 5th power. And then now, because my bases are equal, we know that x has to be a 5.
Will any
right?
of these be on a non-calculated section? Because I don't want to find exponent.
You're just going to have one portion this time, calculator. So you'll be able to use your calculator. Yep.
Okay, because it was still on calculator.
It'll all be calculator. Yep, so you don't have to worry. Okay, 49. We don't want to deal with fractions, so we're going to change this into 49 to the -1st power. And since the left side has a base of 7, let's change 49 into 7 squared. right? So this is 49 is 7 squared, but then that's still raised to the negative first power. And my exponent rules tell me power to a power, we're just going to multiply those. So that is 7 to the negative second power. And now that my bases are equal, we know that x has to be negative 2 in order for those to be equal.
What's happening downstairs?
It's upstairs. They're moving chairs and desks. Happens all the time. All right. 1/2. Again, we're going to change that as 2 to the negative first. And then because we have a base of 2 on the left side, we want to write 32 with the base of 2. So 32 is 2 to the 5th power. Okay, my exponent rules tell me we're going to multiply that to get negative x. And that equals 5. Divide both sides by negative 1. And we get x equals negative 5. Simplify the expression. So this is using our inverse properties that we learned yesterday or the day before, I can't remember. But natural log and e, so those just cancel, and we get the exponent 2x minus 1. Same thing here. E raised to the natural log cancels, so we get negative 4 plus our exponent, which is x to the 4. And those are not like terms, so we can't add those. And then again, e raised to the natural log, we just get x squared.
Doesn't matter if the x to the 4th or negative 4 is in front or behind.
Doesn't matter. Doesn't matter. All right, so now we have some exponential equations. First step, you have to isolate your exponential part. Second step, we're going to take the natural log of both sides. So our exponential part is already isolated here. So that first step's done. The second step is that we're going to take the natural log of both sides. So then, at the same time, I'm going to take my exponent and bring it down to the front. So 5x times natural log of 6 equals natural log of 30,000.
These are all assumed to be natural logs for 10.
It's actually, natural log is log base e.
Okay.
Actually, yep. Yep, and then we're going to isolate x, because that's what we're trying to solve for. So we're going to divide by 5 natural log of 6. And if you divide one side, you have to divide the other side as well. And we get x equals, and then we just need to type this in our calculator. However, when you type it in your calculator, if you do it in one step, you have to put the denominator in parentheses. You do not want this divided by 5 times natural log of 6. And if you don't put parentheses, that's what your calculator is going to do. Or you can use your fraction key, and then you don't have to worry about it. Okay? Yeah.
Oh, where's the fraction key in?
It's
Alpha y equals. Yep, so the green button.
Thanks.
Yep. So natural log of 3,000 divided by 5 natural log of 6 is 0.894. And we're always going to go 3 decimal places, and that's what your homework's going to ask you for tonight.
Any
So,
units or labels?
nope, just 0.894. B, we have to isolate the exponential part first. So I'm going to divide both sides by 1,000. And we get e to the negative 4x equals 0.075. My exponential part's isolated, so my second step is to take the natural log of both sides. So let's take the natural log of both sides. And then I'm also going to bring that exponent down front at the same time. So we have negative 4x, natural log of e, equals natural log of 0.075. And we learned yesterday that the natural log of e, those undo each other. So I guess cancel is not really the right word, but I'm gonna just keep saying that. They cancel. And we get negative 4x equals our natural log of 0.075. And my last step to get x by itself is to divide by negative 4. So we'll type that in our calculator. Natural log of 0.075 divided by negative 4 is 0.648. And again, we probably didn't need 3 examples, but we're going to do it anyways. So C, we need to isolate the exponential part, so we're going to isolate e to the x power. So first I'm going to add the 14 over, and we get 3e to the x power equals 25. Then divide by 3, and now we have our exponential part simplified. When you have fractions like this, you don't need to plug it in and get a decimal. Okay, just leave it as a fraction, and we'll do that at the end, because we're going to have to type it in at the end anyways. So instead of typing it in, just leave it as a fraction, and we'll do all the work at the end. Now that it's isolated, now we can take the natural log of both sides and bring our exponent down.
Are we taking the natural log of both sides to cancel out the natural logarithm?
No, because here we had a 6, so that those didn't cancel out. Yeah. Alright, so we have x natural log of e equals natural log of 25 thirds. And then, again, these cancel out just like they did in the last example. And we just get x equals, and we have to plug that in. Natural log of 25 divided by 3 is 2.120. Any questions on that section? So those are exponential equations. Like Riley noticed, it is really nice when our base is e, because then they do cancel. But if you do have a base that's a number, like we had a 6 here, that's fine. It's just a little bit more work. All right, solve the exponential equation algebraically. We're going to use something here called u substitution, which gets used in calculus quite a bit. Okay, we're going to let u equal e to the x. Okay, again, it's called u substitution. So we're going to substitute u in for e to the x. So here, e to the x, and we have e to the x, so we're going to replace those with a u. So this first one, we have u squared, okay, because the 2 is still there, minus 3u plus 2 equals 0. The reason we use u substitution is so it makes it easier to factor.
Why do we use, is it just a random letter? Does it matter the letter?
Yes, use u, because that's what you're going to use next year.
Lowercase or uppercase?
You technically could use lowercase. You technically could use any letter, but we usually use lowercase u. So we factor this. What multiplies to 2 and adds to negative 3, that's going to be negative 2 and negative 1. And then we set each factor equal to 0 and solve. So we get u equals 2 and u equals 1. And then we said that u was e to the x power, so we're going to plug that back in. So e to the x equals 2 and e to the x equals 1. And now we have two exponential equations that we need to solve. So let's take the natural log of both sides and bring the exponent down. So we get x natural log of e equals natural log of 2. But the natural log of e cancels, and we just get x equals natural log of 2. Plug that in your calculator, and we get 0.693. And then we can do the same thing over here, unless you guys recognize e to what power equals 1? 0, yeah. So you could just, right, since you already know that answer. But if you did take the natural log of both sides and bring the exponent down, it would look like this. And you'd get x equals the natural log of 1. Well, the natural log of 1 is 0. So you'd get the same thing if you did the same process, but if you recognize from the beginning that e to the 0 power is 1, then you can just be done there. Yeah?
Can you just take the natural log of what u equals? Because it's the same thing.
I see what you're saying. So you take the natural log at this step.
Once you do that, so
You could, but you're going to have to plug e back in at some point.
Oh, yeah.
So, yeah. Yeah. So I would just replace it, then solve the exponential equation. All right. Same thing. Solve the exponential equation algebraically. Ultimately, our first goal is to isolate our exponential part. How do we do that? Well, right now it's in the denominator. Where do you think we need to put it? In the numerator. So let's multiply both sides by e to the 6x minus 14. If I do it to one side, I have to do it to the other. So we get 119 equals 7e to the 6x minus 98. We'll add 98 to both sides because we're trying to isolate our power. Okay, so add 98, and that is 217 equals 7e to the 6x power. One last step, divide both sides by 7, and we get 31 equals e to the 6x power. And now we finally have isolated our exponential part. So we need to take the natural log of both sides now and bring down our exponent. So we have the natural log of 31 equals equals 6x times the natural log of e. That just cancels, natural log of e. So my last step is to get x by itself. So we're going to divide both sides by 6. So type that in. Natural log of 31 divided by 6 is 0.572. Again, 3 decimal places, and that's what your homework is going to ask you for. So again, our ultimate goal is to isolate the exponential part, then we can take the natural log of both sides. All right, our exponential part's already isolated. We have 2 different powers. We have 1 and 2. Okay? So that's done. They're isolated on their own respective sides. So our next step is to take the natural log of both sides. So we're going to take the natural log and bring our exponent down. Take the natural log and bring our exponent down. When you bring the exponent down, you need to put the exponent in parentheses. Okay, because it's the exponent times the natural log of 5 equals the exponent in parentheses times the natural log of 3. That means we're multiplying these, which means I'm going to have to distribute the natural log of 5 and distribute the natural log of 3. So we get x natural log of 5 plus 2 natural log of 5 equals 2x natural log of 3 minus natural log of 3. The key thing here is remembering you have to put the exponent in parentheses so that you remember to distribute. From here, it's just solving an equation. It's the same concept. We have a variable term here, and we have a variable term here. So we have 2 variable terms. We want to get the variable terms on one side. Then we have constants. A constant is just a number. This is just a number. We don't know what it is, but right? We haven't plugged it in, but it's just a number. Again, this is just a number. So we want variable terms on one side, constants on the other. Doesn't matter which side, but I'm going to keep my variable terms positive, so I'm going to keep them on the right side. So I'm going to subtract. Yeah, actually, it really doesn't matter what side you put it on. I'm going to put my variable terms on the right side. And then I'm going to put my constants on the left side. So on the left side, we have, these are not like terms, so you can't add them. We have 2 natural log of 5 plus the natural log of 3, which is just going to be some number, right, when we plug it in. On the right side, we have 2x natural log of 3 minus x natural log of 5. And from here, we're trying to isolate x. I'm trying to get it by itself. So we have an x in this term and an x in this term. So we're going to pull out a GCF of x on our right-hand side. And now all we have, and I'm not going to rewrite this again, I'll just do the work from here. There we go. Okay, so the only step we have now, we have a number equals x times a number. So we need to isolate x and get it by itself. So we're going to divide this side by this number, and then divide this side by that number. Okay. When you type this in your calculator, use the fraction key. If you don't have the fraction key because you have an older calculator, make sure you either do the numerator, hit enter, then do the denominator. If you do it in one step, just make sure you put the denominator in parentheses. Okay? So we'll plug this in. 2 ln 5 plus ln of 3 over 2 ln of 3 minus ln of 5 7.345. We did problems exactly like this last year. I remember they were definitely a struggle on the test. But again, just you got to remember to distribute here, and then you have to think of it in terms of variables and constants. Right? These are just numbers. So, all right. So far we've just done exponential equations. Now we're going to do logarithmic equations. Okay, we have logs on both sides. So here's what we're going to do when we have all logarithmic terms. First, we're going to condense the log terms. What does that mean? Okay, well, we just want a log and a log. But right now I have this extra thing here, the -1. So we're going to condense that. What does that mean? We're going to use our power property, and we're going to make that an exponent of -1. So we're condensing. Okay, so now we have log base 3 of x minus 2 equals log base 3 of x minus 8 to the negative first power. Right? And now we just have the log and a log, nothing else. Right? So we don't have any numbers in front of it, being added to it, being subtracted, being multiplied, nothing like that. So now we've isolated, we've condensed the log terms. Now we can drop the log terms because of this property right here. Okay, x equals y. So we can drop the logs, and we get x minus 2 equals x minus 8 to the negative first.
So it's in the denominator.
Yep, so move it to the denominator. So that's 1 over x minus 8 to the positive first power. And we're trying to isolate x, so we need to get all the x's on the same side.
So you multiply.
Yep, so multiply both sides by x minus 8. And when you multiply the left side, you now have a binomial times a binomial. So we're going to FOIL this. First times first is x squared. Minus 2x minus 8x is minus 10x. And negative 8 times negative 2 is positive 16. And then what are we left with on the right-hand side?
Nothing.
1.
Sorry.
1. No, you're good. So there is a 1 there, right, in the numerator. So now we do want to get this set equal to 0 so that we can solve our quadratic. So we are going to subtract the 1 over, and we get x squared minus 10x plus 15 equals 0. Sometimes they'll factor and sometimes they won't. This one, what multiplies to 15 and adds to negative 10? Nothing. So we have to use quadratic formula now. So let's do that. X equals negative times negative 10, so positive 10, plus or minus negative 10 squared, which is positive 100, minus 4 times 1 times positive 15, so that's minus 60, all over 2 times 1. Okay, so that's 10 plus or minus the square root of 40. And does 40 have any perfect square factors?
4.
4 and 10, yep. So I'm going to rewrite this as 4 times 10. And then the square root of 4 is 2. So 10 plus or minus 2 root 10 all over 2. Do my 3 outside numbers simplify?
Yeah.
Yep. So pull a 2 out of each of them. So that's 1, and that's 5. So x equals 5 plus or minus root 10. But that's not it. That's not it. So let me go back to the rules. We have to check the domain for restrictions because the argument of logarithm cannot be negative or 0. Can't be 0 or negative. Therefore, I have to make sure that these values, when I plug them in, I'm going to have all positive arguments. So in order to do that, I need to figure out what these solutions are as decimals. So 5 plus the square root of 10 is an exact answer. When we plug it in, that's going to be an approximate answer. So that's 8.162. And then 5 minus the square root of 10 is 1.838. So you can just do a quick check. 8.1 If I plug in 8.1, that's going to remain positive. 8.1, that's going to remain positive. Okay, so we're good. That is one of our solutions. Okay, how about 1.8? 1.8 minus 2, that's negative. So we can stop there. But if you were to plug in a 1.8 here, that argument's also negative. They don't both have, if you have one negative argument, that's not a solution. So remember we call this an extraneous solution because it appears like it was a solution, but it actually wasn't. So we call it extraneous. It's not a solution, so we just have our one solution. Again, because our argument cannot be negative. So anytime you have a logarithmic equation, you have to check the domain for restrictions. So we just did an example like this. We're going to get to an example like this. Okay, solve the logarithmic equation algebraically. We have all logarithmic terms again. So I'll need to make up an example where we don't, to make sure we can cover everything. I think, not that one. Okay. Alright, so we need to condense. That's our first step. So we have the subtraction here. We learned yesterday that means we can divide the arguments. So we have the natural log of x plus 5 over x minus 2. So again, that's using the quotient property that we learned yesterday. And then it equals the natural log of x. Now that we've condensed both sides, we can drop the natural log, and we just get x plus 5 over x minus 2 equals x. Okay, let's get rid of the denominator here, so let's multiply by x minus 2 times x minus 2. So x plus 5 equals x squared minus 2x. Let's set this equal to 0 so that we have a quadratic that we can solve. So we'll subtract x, and then we'll also subtract the 5. So that's 0 on the left side. X squared minus 3x minus 5 on the right side. We'll multiply to 5 and adds to negative 3. Nothing. So x equals negative times negative 3. So that's positive 3 plus or minus the square root of 9 minus 4 times 1 times negative 5. So negative 4 times negative 5, that's going to be a positive 20 all over 2 times 1. So we have 3 plus or minus the square root of 29. That can't be simplified over 2. Again, we have to check the domain for restriction. So I'm going to figure out what those are as decimals. 3 plus the square root of 29 divided by 2 is 4.193. And 3 minus the square root of 29 divided by 2 is negative 1.193. Okay, so let's see. 4.1, yeah, both of the arguments will be positive. Negative 1.1, positive. Negative 1.1 minus 2, that's a negative argument. So this one cannot be a solution because it's extraneous. Okay. Notice here we had a negative solution that was extraneous, but you saw here we had a positive solution that was extraneous. So you just have to plug it in and check the arguments. You can't say, oh, well, if it's negative, it's automatically extraneous. That's not true. Right? It just depends on what the arguments are. So you do have to do a quick check. So there's our 3 plus the square root of 29 is our exact answer, and that's our decimal answer, 4.193. I feel like we didn't do...
We did this last one yesterday.
What?
We did a impress one yesterday.
Yeah, I'm going to add an example here. We might not have time for the last one. That's okay. We can do that one tomorrow. There's none on your homework that are like the last one, so I want to make sure. So, add this in somewhere. You have room somewhere, right? Yeah. Or you can do it on the back page. Yeah, how did I? Okay, I don't know how I did not put an example like this in. We have one log term. So here's my rules for that. Group the log terms. We only have one here. Condense them. We'll change the natural log to log base e so that we can swirl. And once we swirl, that's just using the definition of log. And then we also have to check the domain. So, again, we're going to change this to log base e just so that we can swirl. There are other ways to do this problem. Okay, there's other ways. Okay, so this is not the only correct way to do this problem. And if you like a different method better, that's totally fine. So let's swirl. E to the second power gives me x plus 1 quantity squared. Now we're just solving for x. Let's just isolate x. Square root both sides. When you square root, you need a plus or a minus. And then we have plus or minus. Oh, well, what's the square root of e squared? That's just e. Yep. Equals x plus 1. Subtract 1 from both sides. And we're done. Negative 1 plus or minus e equals x. But I think your book, yeah, 3 decimal places. The e on your calculator is the second divide by sign. So e is second, and then the divide by key. That's where you get the e on your calculator. We don't want the e with the exponent. We just want negative 1 plus second divide and negative 1 minus second divide. And we get x equals 1.718 and negative 3.718. But we have to check our domain. We can't have a negative domain. So let's see. 1.7 plus 1, that'll be positive. Negative 3.7 plus 1 is negative 2, but we're squaring it, so it will be positive. So we're fine. So yep, both of those work. And that's number 107 in your homework. So you can, that one is done. So that should help you with the section before. The first step, make sure your natural log gets isolated. Okay, if there was like a 5 here, then you'd have to divide by 5 first. And then you can do what we just did. Okay, so you got to isolate it first, then you can do that. I will take questions on your homework tomorrow, then we'll review, and then we'll do the quiz. So there's 3 questions from today.
What's happening?
No.
Where'd you put my ring? It was definitely not out there. I don't believe it's there. I put it a little bit out there. You didn't make it.
Alright.
You're making a little origami thing. I know I know. You're putting away in. It was not fixed baby. I mean, well, like they're folded, but like they're not dangerous. Like they're really thing. Then I put safety hats on. To make it like a box. Okay, that's way too far. Alright, don't